Okay, I think we'll go ahead and try to get started. One of our speakers hasn't arrived yet, but hopefully she'll arrive a little later. That's Lucia Feiss, and if she does arrive, we'll just slot her in at the back of the presentation. So welcome back from lunch. It's a tough time of the day after listening to a lot of presentations in the morning, but I think we have a nice presentation here this afternoon. Energy conservation, as you all know, is both in our present now and will absolutely be part of our future. With a number of the different initiatives around the world in terms of building performance, trying to get to net zero, triple net zero living building initiatives in the US, the AIA's 2030 initiatives, some of the things that are happening in Europe and Asia now. The methodologies by which we're going to have to achieve much higher performing buildings are the kinds of things that we're exploring today, and we'll have to look towards a great deal of new technologies in the future. Today's panel of speakers approaches this from a number of different angles. Some things that are state-of-the-art using today's technology and how they're going to be engaged in the buildings. Some things at the urban scale, and also looking a little bit towards the future. So I think it'll be an interesting conversation. With that, I'd like to welcome our first speaker, Seongsil Kim. She is a manager at LG Electronics and a professional engineer of building mechanical plumbing engineering systems. She's currently a consultant of HVAC systems design and is also working on heat pumps in particular, and that'll be the topic, a case study of HVAC systems using heat pumps in tall buildings. So with that, I'd like to welcome Seongsil and listen to her presentation.
Good afternoon, everyone. Let me start by introducing myself. My name is Seongsil Kim. I work in LG Electronics AE Company. AE Company has air conditioning system and energy solutions. Air conditioning system is HVAC system using heat pump system, and energy solutions are LED and PLS lighting, solar cell, and building energy management system. Well, now I will start presentation. The topic of today's presentation is a case study of HVAC system using heat pump in tall buildings. The object of this presentation is to present energy saving effect using heat pump system in tall buildings. This presentation divided into 4 parts. First is introduction and this presentation and LG total solution. Second, what is heat pump system? Third, HVAC application case. I will present 4 cases. Then finally, I will finish with my conclusion. Generally, a tall building is over the height of 200 meters and 30 or 50-story building in Korea. A tall building have many energy and environmental problems. First, tall building is not easy for ventilation because of air pressure drop and stag effect. Second, heat loss due to the infiltration. Third, using light construction materials needed for building load, so building needs a lot of energy for heating and cooling. So these buildings need to more powerful and efficient air conditioning and ventilation system. So energy saving is critical issue in the tall buildings. Moreover, the world is facing an energy crisis due to depletion of fused foods. So energy saving is a very important problem. This is show the building energy patterns, energy consumption patterns in Korea. Building energy consumption is almost 25%. The big part energy consumption is industrial part. So many company try to energy saving for industrial part. But now today I will focus building energy consumption. Moreover, we recognized almost energy consumption of almost 50% is using HVAC and lighting system. So we need energy saving for HVAC and lighting system control and use high efficient HVAC and lighting system. So LG suggests the total solution to solve the problem. The LG total system is HVAC and energy solution. Total solutions items are as follows. First item is high efficient heat pump. The heat pump is core product is LG total solution. It used for heating and cooling a building using inverter technology. Second, geothermal heat pump. Geothermal heat pump use of renewable energy for heating, cooling, and hot water heating. The renewable energy is a hot issue about solving energy problems. Air handling unit. If you want air conditioning in large space, you can use this air handling unit. Heat pump water heater. It is better efficiency approximately 3 times to 4 times than boiler. Chiller is a core product, the central HVAC system. Heat recovery ventilation is waste heat source recovery ventilator of air tightness building for air conditioning. And LED lighting is Energy Solutions core product. It is high efficiency lighting for indoor and outdoor lighting. PLS is plasma lighting system. It is for outdoor and street lighting. The last is building energy management system is based remote control service and maintenance. So you can see this picture. LG is full lineup for energy and air conditioning system. If you integrated energy solution, can save energy consumption in building by up to 30%. 30%. And then now I describe the heat pump system. I previously mentioned the heat pump is core product LG total solution. Heat pump is machine for heating and cooling system. For heating, the principle of working of the heat pump system is as very similar is just air conditioner. It is cooling mode. If we want cooling, input electric energy, and then refrigerant flow this load, and then this is the room. You can use cooling heat. And then heating mode, this is room, this is outdoor. Input electric energy and refrigerant flow this. So you can use the hot heat in the room. Now I want to describe efficiency of heat pump. Heat pump is four times the heat as input electric energy. If you want make heat, you have a boiler and heat pump. And if you have 100 units of fuel, if you use boiler for heat, you just make 90 kilowatts of heat, because 10 kilowatts of heat is lost. But if you have a heat pump for heating, you make 160 kilowatts of heat, because 100 unit of fuel make the 40 kilowatt electricity, and then input the electricity in the heat pump, you make 160 kilowatts of heat, because heat pump performance is 4 times input electric energy. This picture describes the effect of energy saving and reducing carbon dioxide using heat pump. If we want make the heat just 10 kilowatt, and then if you use a boiler, you need 111 units of fuel. But if you use the heat pump, you just need 62.5 units of fuel. So energy saving by 44%, and carbon dioxide emitting reduction by 54%. This is LG heat pump system. This is LG heat pump and using parts product. This is heat source. We use heat source is air, water, and geothermal. And you can use the conventional energy. And using this heat and make the heat in heat pump using various type of indoor unit. If you want a large space heating and cooling, you use air handling unit. And there are many rooms, and you want to control individually, you can use this indoor unit. This is ceiling type and floor type. And heat pump can make hot water using hydro kit. From now on, I'm going to explain about HVAC application cases of buildings. Previously mentioned, I will present 4 cases. It is the first case of building. This building is 64-floor high-rise residential complex building. This building used water-cooled heat pump. This is a schematic diagram of heating and cooling. This building used water-cooled heat pump and heat distributed by duct. This damper is automatically open and close the damper depending on the room vacancy, depending on the load pattern, so it can save energy. This is the second case. This is also a residential complex building. This building is 47 stories. It is also used water-cooled heat pump, but indoor unit is different people. This is a schematic diagram. Is this building air conditioning? In this building used ceiling type indoor unit. This unit is operated individually. So user want on and off, you can operate easily. The third case is commercial building office. This building is R&D center. This building used also water-cooled heat pump, because water-cooled heat pump is high-rise building fit well with high-rise building. This is a schematic diagram heat and cooling system. In this building, there are many various using pattern of rooms, such as lobby and auditorium and conference room and individual office room. So we provide indoor units depending on the using pattern. Office room is want to operate individually, so user on and off individually. Especially this building is control system is for energy saving. Water-cooled heat pump system make the heat must using cooling tower and boiler. When this building wants cooling, must operate cooling tower, and when they want heating, operate boiler. But in the building, heating and cooling load at the same time. This building not operate cooling tower and boiler, just circulating and then heating and cooling at the same time. So this building energy saving effect very high. The last case is this is building 80 story of a building. This building use air-cooled heat pump. This is schematic diagram used in this building. This building use air-cooled heat pump. The name is multi-V space. It's developed fits well with tall residential building, and use heat recovery ventilator. This heat pump is indoor units operate individually. This is the property of multiple space. If you use conventional air-cooled heat pump system, the heat column occurred in this building. So the high-rise space is heat pump performance is very reduced, but multiple space is airway out, right and left, so it's not a hot column effect not occurred. So the building performance is very high. And then in this building applied the energy recovery ventilating system. Tall building need artificial ventilating system because they cannot open the window. However, air ventilation not enough because of pressure drop in the long duct. So LG's heat recovery ventilator is made to reduce problem by using booster fan, so it can bring very fresh air into your space. Now, I will finish with my conclusion. I have explained the energy saving effect using heat pump system. In conclusion, if you use heat pump system, you can not only save energy, but also provide an optical HVAC system that maintain eco-friendly buildings. This is LG Electronics direction. So I want to about LG Electronics direction of world environment. As a responsible member of a global community, LG has taken an initiative in corporate social responsibility program focusing on eco-friendly and poverty relief activity at global scale through its 3-point L, G, E, love and care, globalization, environment. LG is a strong commit to showing its respect for the people and the planet. Thank you for your attention.
Okay, thank you, Dr.